I found that E is 5.4 joules. So here is so my potential energy was this much, plus I had a bit of kinetic energy. This is kinetic energy initial. This much is potential energy initial. And that's how I figured out how much energy I had. Okay? Now, by looking at this graph, I can say a lot about the motion. First, I started the motion at position 0.3. Okay? And this goes on. Conserving the total amount of energy. Okay? At the initial point, I gave a velocity plus 3 meters per second. So it's moving to the right. As it moves to the right in that figure, what happens to its total energy? It remains fixed. This red line is always total energy. So when it comes from 0.3 meters to 0.4 meters, let's say, what happens? Has the potential energy increased as I go to the right? Yes? Okay, let me point it out here. Okay, so as I move towards the right, the potential energy is increasing or decreasing? Increasing. The total energy is fixed, so the kinetic energy is decreasing. That means the object is still moving to the right, but with less and less velocity. Why? Because the spring is pulling it back. I could do it in terms of force. It's getting acceleration backwards. Less speed, right? But here I can see, just from this plot, how exactly the kinetic energy is decreasing. As the kinetic energy decreases, what will happen? Eventually, the kinetic energy will drop to 0. Right? Where? Here. Okay? At that point, what is the speed? Speed is 0. Okay? And what will happen afterwards? Right? It cannot move any further to the right. Because if it did, there is so much potential energy, it would have negative kinetic energy. You cannot have less than 0 kinetic energy because its velocity is square. So the only thing it can do from that point on is to turn back. Okay? Let's figure out where that point is. This is the turning point. The maximum value of x. Okay? That's the point where the kinetic energy is 0. Potential energy at x max equals the total energy, which is 5.4. Okay? So now you can figure out 10 times x max squared. Why? Because that is the potential energy in this problem. Okay? Potential energy is something times x squared in this problem. So at that point, the full total energy of 5.4 joules is entirely potential energy. At such a point, the thing will turn around. Okay? Does everybody understand the example? Now let me ask you a question. Let's come back here to our plot. Where on this plot is the particle, is the object going to move fastest? Yeah. Your friend says when potential energy is 0. What will happen is it will come, first I pushed it to the right with some velocity initially. It can move to the right, has to stop at this point, start turning back as the spring pulls it back. Okay? As it turns back, now the potential energy is decreasing. The full total energy is still the same. Okay? So, kinetic energy is increasing. It's moving towards the center faster and faster. So the biggest kinetic energy is where potential energy is minimum. In this example, the potential energy is 0 at the minimum. We usually choose it to be 0 at one of the minimum points. Okay? So at the central point, at x equals 0, kinetic energy is just the total energy. All of your 5.4 joules, when it passes through the center, goes to velocity, to speed. Okay? And you can figure it out. What was it? It was 1/2 mv square, m is 1. Okay? So 1/2 of v square is 5.4 joules. V square is 10.8 joules, so v is the square root of that. That's the maximum speed. Now, when it gets to the center, what will happen? Can it stop here? No, because it has a velocity. Okay? There is a force, but all that the force does is it can try to change the velocity a little bit, but only a little bit. In any case, the force right at the bottom of the potential, you can see from the potential energy curve what the force is at this point. What is it? Well, remember, the relation between force and potential energy is that if you take the derivative of the potential energy, put a minus sign in front, that gives you the force. At this bottom point of the potential energy, what is the derivative? Is 0. Remember, when you make a graph geometrically, the derivative is always the slope. Here, the slope is flat. So the force is 0 here. So it comes here with maximum velocity. The force could change it a little bit, but not a lot. In any case, the force here is 0. So it just continues. Okay? Because it has momentum. Goes to the other side. And now what happens? As it moves here to x on this side, like x equals -1, -2, whatever, the potential energy is increasing. So the kinetic energy is decreasing until it comes to this point, which is just minus the other point. Okay? Where it stops, and now the spring pulls it back. So you can see everything in the motion just by studying the potential energy curve. Put on the potential energy curve what the total energy is. How do you know the total energy? Well, that is given by the initial conditions. Where you put the particle initially and what kind of kick you gave it. You can calculate that, and that gives you how much energy it started with. And then you draw a flat line, because that energy is going to be fixed. As it moves from point to point, potential energy changes. Subtract from kinetic energy, from total energy, that tells you at each point how much energy is kinetic, therefore what's the velocity. So you can tell where it is fast, where it is slow, where it will stop. You can have a quick overview of the entire motion if you have the potential energy curve. Okay? Now let us study some potential energy curves. Okay. Here's another one-dimensional potential energy. This is not the spring. It is some other thing. It could be some other thing, okay? For example, in this kind of potential energy, it could be that you are talking about gravity near the surface of the Earth, and U of x is just mg times z of x. What does z of x mean? Well, suppose you are going for a walk over the mountains. You take a straight path, okay? And you call that distance along the path x. As you go along x, you climb the mountain. The height of the mountain you call z. So your height, your altitude changes as you move further in your trek up the mountain. Z is that, okay? Now, if you consider gravity, which is pulling you back and making it difficult to climb up the mountain, right? The potential energy due to gravity is just mg times z, right? That's one example of potential energy. As I said before, that is not potential energy in general. But in this problem, it is the potential energy.